Alright, so this problem is talking about the rate of snowfall. So graph is given to you, talking about how much snowfall over a period of time. So if you can think of this, snowfall is going to fall on the ground, and over the time it's going to accumulate, so we're going to end up with more snow, and then at a certain point the snow may melt and we're going to lose some snow, so the rate is changing. So let's think of that way. Okay, if we look at this graph, it's telling you, the graph is giving you in terms of the rate of snow fallen. So anything there's a movement attached, we talk about the rate. So this graph is in terms of the derivative. Okay. Now, let's recall, if the graph is in derivative terms, so this telling you the reason it's derivative because it's talking about snow is falling and melting. So if we look at this one, x-axis, you can think of this as the ground level. Okay, and when the snow is fallen, anything above the ground means we have more snow and more snow. So the rate going to be positive. So the slope is positive or the rate is positive. Anything below the ground or below the x-axis means we're losing the snow, it's melting, the rate is slowing down, it's decreasing. So if you can think of that way. So we look at the amount of snow over the period of time. Alright, so this table is asking us to find the snow from the 0 hours to the 8 hours. So think about accumulation of snow. It's the total amount of snow. So that we know that is the area situation because we're going to look at the total amount. Okay, so when x is 0, it's going to be easy. It's going to be 0 because there's nothing yet. When it's at 1, this is 1. So this is the piece that we want. This is the total snow from 0 to 1. If you look at this one, you see that's a trapezoid. And we learn how to find the total area by looking at the shape. Recall from Monday, right? We have the shape. So this is the trapezoid. So area, base 1 is 1, base 2 is 3, the height is 1. So we're going to use the trapezoid, which is 1/2 times the base is 1, base 1 plus base 2, that would give us 2. And now we're going to find area when x is 2, when it's 2 hours later, which is we're going to add one more piece, right? So we want to find the total of snow from 0 to 2. That means it's this trapezoid and this rectangle. We know the trapezoid is 2, so I'm going to write that down. We're going to find how the total, the area of this rectangle, which is the base is 1, height is 3, so that would be 3. Again, we talk about total, so when x is 2, when it's 2 hours later, we have a total of 5, because 2 plus 3, right? Then when it's at 3, again, 3 is this piece right here that we're going to look at. 3 is this piece right here that we're going to look at. Alright, so when it's at 3, we want this area, which is this piece. We're going to add one more. So this one is 1 by 3. So the area going to be 3 times 1/2 times 1 times 3, which is 1.5. Again, when it's 3, we want to find the total of these 3 pieces, so that would give us 6.5. Okay. And then when it's at 4, when this is at 4, right? So we're going to add this piece, which is a rectangle again. So let's see, the base is 1, the height is 4. So 1/2 of that would give us a negative, because it's below, so we will give that as a -2, right? Anything below will give us a negative area. So we add them up, 2 plus 3 plus 1.5 plus negative 2. That will give us 4.5. And then when we look at 5, that means 5 is right here. We want another piece, which is this area right here. Again, the base is 1, the height is 4. So this is another negative 2. So if it's at 4.5 and we add the negative 2, so that would give us 2.5. When it's at 6, which is right here, so this piece that we're going to get is 1 by 1. So the area of this area of the triangle is going to be 0.5. And this is positive because it's above the x-axis. So we can add that when it's at 6, it's about 0.5. So that will give us 3. So 2.5 plus 3. So at 6.5, which is this piece right here, if you calculate the area of this small triangle, and if we add it as 0.25, so we can say it's 3.25. When it's at 7, so this is the piece right here that we add. Actually, because this area is negative, so we're going to minus. So this is about 2.5 right here again, so that's what give us just 3. And when it's at 8, we're going to minus this area right here because it's negative, which is a 1 by 1, so that would give us 2. Okay, if you have any question about how I come up with these numbers, please see us on, at the end of the day on Monday, because we have office hours. It's really important if you understand where these numbers come from. Okay, so again, it's the area from 0 to the point that we calculate. So if it's at 1, that means from 0 to 1. What is the total area? If it's at 4, the total of area from 0 to 4. Anything above is positive, below is negative. So when I add them, I ended up taking away some of the area because think about snow is melting, so we're losing the amount of snow right there. Okay, so if we want to take the derivative, if we look at this one, now we consider from 0 to x. If we take the derivative of integral, what will you expect to happen? Okay. So if we complete the chart and so this is mean the derivative. Okay, so if we take the derivative of that, this is what we're going to end up. So remember today when we talk about second derivative, second fundamental of theorem of calculus, f of t, if we replace in, we do the shortcut, what is instead of t, we replace in by dx times for dx over du's, right? Time for the derivative of the x values. In this case, if we look at this, the x is just the x value, sorry. It's just the x values. So by look at this, the derivative is just 1, so we don't have to write that. So if we take the derivative of this integral right here, we will just end up with f of x. So we can say that f prime of x is the same as x, which means the rate, or what we call as the derivative. Okay, sorry, let me rewrite the word derivative. So the derivative. Okay. All right. So what we can say is that so is the same thing as derivative. Okay. So we know in that we already complete the chart. And my apology, I copy the chart again just so that we don't have, so you can see that. So let me fill that out. So the one that we've filled out is f of x. The first table is f of x, and this one is f prime of x, which is f of x, right? We just talked about it. We took the derivative and we replaced in the x. Instead of t, we're replacing that with x. So f of t is the same as the integral from 0 to x, f of t dx is the same as f of x. So this is f of x, right? So if you think, let's go back to the graph, and this is the graph that's given to you. So we're not looking at the area. For this one, we actually look at the graph and look at the point is on the graph. So when x is 0, if we go back and look at the graph, when x is 0, the y value is 1. When x is 1, the y value is 3. So we talk about the y value. We actually look at the graph, we look at the function, we not interpret that as area, we just basically look at the graph and tell the point on the graph. When x is 2, the y value is 3, 0, negative 4, 0, 6. So let's think what 6 would be, right? It should be 1. 6.5, if you look, is on the x-axis, which is 0. When it's 7 is negative 1, and when it's a is negative 1 as well. It's at the same numbers. Okay, now we talk about on the subinterval from 0 to a, f is increasing or decreasing. So again, this one now we look at f of x, not f prime. This is f prime. This we look at the derivative graph, right? This is the f of x, the original function. Original. Okay. Original. Okay, so increasing, so now we think about in terms of increasing and decreasing. Decreasing mean below the x-axis. Increasing mean above the x-axis. So we look at the graph, it's increasing when it's above the x-axis, which is from 0 to 3. And also from 5 to 6.5, because that is when the graph is above 0, right? And then decreasing is when it's from 3 to 5 and 6.5 to a, because then when that's the graph is below 0. Okay. Again, we spend a lot of times look at the graph and talk about increasing and decreasing. This is the same idea. Alright, when we're on the interval from 0 to 8, does f achieve a minimum and a maximum? So a minimum is when it's decreasing and increasing. Maximum is when it's increasing and decreasing. So what are those values? So if you look at this, the time when it changed from positive to negative is, let's talk about the max. The one time is changing from positive to negative is when x is at 3. And also when x is 6.5. Which just makes sense, right? When x is 3, the snow is fallen, and that's when it just starts to melt. So the snow is still at the most, it still have some snow. So we have we still have snow, and then after that it's decreasing, and then when 6.5 we gain some snow at 5 and we have more. So we look at this, is the max at that point. Okay, minimum, I'm going to put the value x of 0. We think about it minimum because that's when there's nothing yet, so I will include the 0, which we don't see that on the graph. But in this real life problem, we can think of when 0, there's no snow, so we include the 0. And then we will look at the minimum. So in this case, when beside x is 0, minimum when is decreasing to increasing. So we say it's relative min, right? It will be at 5. However, because for this one we're thinking about snow in terms of snow, so we're not going to include the 5 because we talk about snow accumulate. And if we look at this, the area, we have more positive area than negative area. Therefore, we would say the only time it has the minimum is when x is 0. 5, we're not going to be able to count because the total area at 5 is still pretty high. We can say it's relative min, but we're not, in this case, we're not including 5 because we talk about real life, we talk about snowing. It still have snow, it's 2.5, so still more snow when we look at when x is 1, right? So we will not count that. So if you go back to the table, look when x is 5, we have 2.5 snow. And then that's still more than when x is 1, which is not the critical point. So that's why I'm taking out the 5. Concavity and point of inflection. Point of inflection when f prime is changing sign. So let's look, change sign. So let's look at the graph to see when the graph is changing the slope. So we will see that it's changing at x is 4 and when x is at 6. Alright, so we will look at when it's increasing from, so concave up is from 0 to 1 and 4 to 6. Because if you look, the function f prime of x is increasing. And it's concave down from 2 to 4 and from 6 to 7 because f prime of x is decreasing. Okay? We spent a lot of time talking about this. If you're still not sure, ask questions on tomorrow or Monday. Okay? Now the last piece is we're going to sketch the rough sketch of the function. So we have several critical points that we want to look at is one is at 1, 2, 3, 4, 5, 6, 7, and 8. Okay? So let's make the chart. Sitting at 1, 2, 3, 4, 5, 6, 7, and that's 8. 1, 2, 3, 4, and that is 5. Sorry. Let's go back to 4, and that's 5, 6, 7, and 8. Okay? From 0 to 1 is above the x-axis, is increasing. From 1 to 2 is above the axis, but it's not increasing, it's not decreasing, so we're not going to put anything. From 2 to 3 is above the x-axis, but it's decreasing. From 3 to 4 is below the x-axis and decreasing. From 4 to 5 is below the x-axis and increasing. And then 5 to 6, above, increasing. From 6 to 6.5, we need to have a 6.5. I forgot about the 6.5. Right here, so I'm going to add that in. Okay, from 6.5 is above and decreasing, above and decreasing. 6.5 to 7, I'm going to make the 7 here. 7, so from 6.5 to 7 is below and decreasing, and 7 is below, and we don't know the rate because it's not changing. It's the same. So we're going to sketch the graph based on that. So from 0 to 1 is increasing and concave up. So in 0, we start at 0, increasing, concave up. And then from 1 to 2, we don't know it's concave up, but we know it's increasing, so it's a straight line, because I don't know it's concave up or concave down, so I make a straight line. And then from 2 to 3 is increasing and concave down. So increasing, concave down. 3 to 4 is decreasing and concave down. 4 to 5 is decreasing and concave up. 5 to 6 is increasing and concave up. 6 to 6.5 is increasing and concave down. So this is 6.5 that I forgot. From 6.5 to 7 is decreasing and concave down. And then 7 to 8 is decreasing, but I don't know it's concave up or down, so I would make a straight line. Okay, so I'm going to highlight this part. So that's roughly the sketch of f of x, the original function that we looked for. Okay. All right, I know that the sample is a bit long. Hopefully, if you need to go back and look through piece by piece, or if you have questions, again, ask questions on Friday or Monday. Okay. If I make any mistake, let us know. Hopefully, that would help you with your homework.